Alrighty, so derivatives. So the derivative. So first of all, what is a derivative? We'll talk about that. But we have different notations for derivatives. So I'm going to jump ahead a little bit to the middle guy right here, the symbols used. You're going to see some symbols that you might not have seen before. They mean derivative. So all four of these guys, f prime of x, d over dx of f of x, y prime, dy over dx, they all mean derivative of some sort, okay? So dy over dx, so why do we have so many different symbols? Well, it's because different people, well, it's really because two people, I don't want to say invented because they didn't invent, but they came up with calculus. Who's the most famous one with calculus? The guy who the apple hit him in the head. You remember who that is? Newton. Yeah, Newton. Sir Isaac Newton, he did come up with calculus. He did make a lot of strides with calculus. But at the same time, so he was in England back in the 1700s. In Germany at the same time, another guy called Leibniz, Joseph Leibniz, was doing the exact same thing. They didn't know each other. They didn't know each other existed because back then there was no internet. Back then there was no, if you lived in Germany and you lived in England, that took like months to get there because there were no automobiles, so pretty much just those two guys were doing exactly the same thing pretty much at the same time. It didn't look the same because they used different symbols, but essentially they were discovering, that's a better word, discovering, what we're doing now, differential calculus. That's what we're doing, okay? So there's a lot of symbols in calculus. It is what it is. So I'm going to show you a couple things though. First thing, the dy over dx. So this guy, let's see, this guy, this guy, and that guy. The yellow ones means here is the derivative. Okay, so this is the derivative. Anytime you see this guy, which looks very similar, that means that's an action. Find the derivative. If you see d over dx, it means you haven't found the derivative yet. Okay? The yellow ones mean it's already been done, here it is. Okay, so that's the difference. One is a verb, one is an action. The pink is an action. It means find the derivative, it's a command. And the yellow is a noun, here it is. Okay, so what in the world is a derivative? Well, derivative you can break down to a couple words, and they're right here. Slope of the tangent line. Slope of the tangent line, or slope of the line tangent. Okay, so let's start with slope. What is slope? You guys have heard that word since probably junior high, definitely junior high. What is slope? That's slope-intercept form, but what is slope? Just slope. Just slope. Rise over run, right? Rise over run. Up and over, right? Rise over run. Change over time, right? That's what slope is. Slope is just change over time. Change over time. All right, when I get in my car and I'm going down the street and it says 35 miles an hour, that's a slope. It's instantaneous because at that moment, I'm going 35 miles divided by hours, right? That's a slope. You can do it at one instant, or you can do it over, you could have a slope over time, right? So I could have a slope from, I could start when I leave school to when I get to my house, right? How much time did how many miles did I cover divided by how long did it take? Okay, so you can have instantaneous at one, when I look down and it says 35 miles an hour on my car, that means at that instant, my slope is 35 miles per hour, okay? Line, we know what a line is, right? Straight line. Tangent, and I'm talking about so not the tangent like sine, cosine tangent. That's a trig tangent. So we're gonna put trig away for a little bit. What does tangent mean besides those things? So not sine, cosine, tangent, not that kind of tangent. But what is tangent? What does it mean to go off on a tangent? Let me.
Go off the path.
Yeah, go off a path, right? So if someone goes on a tangent, that means they were going on a path and then they kind of veered off somewhere, right? They're talking about something and then they rambled off and got way off track, right? So a tangent is a path. What is a path? Well, a tangent means we hit an object at one place and one place only. So for example, let me draw you a picture. So let's say I have a circle. It could be any shape, but call it a circle. If I was to have a line, right? A line. Every line has a slope, right? Positive, negative, 0, undefined, right? So if I was to draw a line, and that line was to hit this guy at exactly one spot, so only one spot. Say it's at that red dot. Kind of ricochets off of it, right? It hits it and it keeps going, but it's a straight line. We say that this orange line is tangent to the circle at the red dot. What does that mean? It only hits it in one spot, right? Lines can't double back, or else it wouldn't be a line, right? It'd be something else. So when a line goes, it only goes in one direction forever and ever and ever, because it can't switch directions, because then it's not a line, it's something else, right? So it's not like it's going to double back and come back around here. It can't do that because that's not a line anymore. So at the very most, well, it could hit it twice if it went through, right? So if the line went through, it could hit twice, right? That's a secant line. That's a secant line. So we're not talking about that, we're talking about a tangent line. So when you only hit once, if you hit it once. So what a derivative is what is the slope of that orange line at that red dot? That's what derivative means. What is the slope of the orange line at exactly that red dot? When we find derivatives, we're finding the tool that helps us find that. So today, that's what we're going to do. When we find a derivative equation or a derivative function, that's a tool to help us find the actual slope. Okay? So the biggest thing I want you to take away from today is two things. One thing we haven't covered, which we'll do in the problems, and the other thing is, if I say what is a derivative, I should hear slope, tangent, and line, those three words. Slope of the tangent line. Slope of the tangent line. What is a slope? Rise over run. Change over time. What is a tangent? It means it only hits it at one spot. It only hits an object or a shape or whatever it is at one spot, right? Okay. All right. So that's kind of not clicking yet. It's okay. We're going to talk about derivatives for quite a bit. Okay, so this picture, I include this picture just because it comes from our textbook, and then also this guy here, the one that's boxed in is the one we're going to use today. So there's many ways to find a derivative. Today we're going to do what's called the definition of a derivative. The reason I start there is because it should look familiar. Which part of this looks familiar? The limit part, right? We just finished a whole unit on limits. I like to do that first because if I came back to that in a week or two, you'd be like, you might not remember it, but you might remember it. So I wanted to do limits first. So what is the definition uses a limit. The limit as h approaches 0 for all of those guys there. Okay? Is this the only way to find the derivative? No. In fact, on Monday or Tuesday, I'm going to show you a different way to do it. And most of you will prefer the other way, but this way is important. Otherwise, I wouldn't show it to you. Okay? All right, so here we go. Okay? Yeah, because if I showed you just the first way, if I showed you just the second way, you would never even think of this way, and these are on tests a lot. They always show you this. I have students all the time asking me, what is that on the test? And I'm like, it was the very first way we did a derivative, right? That outline. And I'll show you some practice problems. I'll show you some problems, what I'm talking about later. But this kind of outline, students see this and they're like, what does that mean, Remember, it's the derivative. It's how to just finding a derivative. Okay? Okay, so let's go down to example number 1. Okay. They want us to find f prime. So anytime you see prime, f prime, y prime, g prime, that little apostrophe, we call it prime. Okay? If f of x is x squared. Okay? So that's the function here. So the function, the original function is this guy here. We have to find f prime. So what we're going to do today is we're going to use what's called the definition. So the definition is this guy right here. Okay, let me write this down. Let me write it down on the board so we can come back to it. Okay, so f prime means this is the derivative equals a limit. F x plus h minus f of x over h. Okay, so let's go by this one at a time. One thing at a time. Okay, so first thing, let's write it out. I'm not going to write out the whole thing, just as we go. So we have f prime equals, right? It's a limit problem, so the limit as h approaches 0 for this guy. Okay. I'm not going to start with f of x plus h. I like to start with f of x. Because f of x, what is f of x? For this problem, what is f of x? X squared. That part is always given. That part is always given. So whatever f of x is, it goes there. H always goes on the bottom. The first part is always what causes the most issues. What is f of x plus h? Well, how do we do that? How do we figure out what x plus h is? F of x plus h. We knew what f of x was. They told us, right? How do we figure out what f of x plus h is? Let me ask you another, while you're thinking about that, let me ask you a separate question. What is this? How do we do this? Plug in 2, right? Plug in 2 to the original, right? How do we do this? What you just said, Damien, say it again.
Plug in 2a.
Except now plug in 2a everywhere there's x, right? So how do we do this?
X squared plus 8?
No, it's just,
Say, yeah, you're plug in x plus h everywhere there's an x, right? It's the same rule every time. Just because there's something different doesn't mean it's a new rule, right? If we have f of 2, that means plug in 2 everywhere there's an x, right? Okay. 2a, same thing, right? We don't change it. Everywhere there's an x, we plug in 2a. Same thing here. Okay, so let's go to our equation. Let's go to our function. Where is x? Or what is, there's only x, right? So what we're going to do is we're going to plug in x plus h in there. So what is that going to look like?
x plus h squared.
There you go.
Wait, is it? No, is it x squared plus 8?
Right? All we're doing is plugging it in for x. Just like we did for f of 2, just like we did for f of 2a, just like we're doing here. We're plugging in, everywhere we see an x, we're plugging in x plus h. Okay? What do we do now? Go back to last chapter. Last unit? What did we do after that? Picture you had this on the test. What would you do? Plug in 0. Let's plug in 0.
H, though.
Yeah, for h, not for x. We plug it in for h. Okay? So we would get x plus 0 squared, right? Minus x squared over 0. What does that simplify to? Oh, what's x plus 0? X, right? Squared. Minus x squared over 0, right? And that's 0 over 0, yeah. You guys were just saying that, 0 over 0. What was the rule if we found a limit and it gave us 0 over 0? Our work isn't done. Our work isn't done. We have to figure out a way to simplify it. Okay, and we're going to. That's what we're going to do. Okay, so let me rewrite it, and let's look at it a different way. So I'm just rewriting the original. Okay, because we tried it, plug it in 0, and it didn't work. So that means we have to figure out a different way. Okay, so what's one way I could simplify this? Separate, say that again? You're right, we're going to do something with x plus h. What should we do?
Square it.
Say it, Leah.
Square it.
Yeah, square it, like multiply it, right? Multiply it. It's squared, right? It's x plus h squared. Let's multiply it, right? Doesn't that, that's just x plus h times x plus h. So let's see. So let's take this part here, and we're going to multiply it. So let me take a little detour over here. Because really it's just x plus h times x plus h, right? When we're multiplying binomials, we multiply first, outer, inner, last. So first is x times x, outer, positive x times h, inner, x plus h, last, h squared. These two guys are common or like terms, so we can add them together. And what do we get when we add them together? Two of them, right? Two xh's. I'm going to move all that stuff back to the yellow. I'm going to move all that stuff back into the yellow.
That's a lot.
Yeah, it's three terms, right? It's three terms now. So I got x squared plus 2xh minus x squared. Oops, no, so forgot the plus h squared. Minus x squared over h. Hold on, thanks. Okay. When we do that, what happens next? Look at what we have so far over there. The x squareds on top cancel out, right? Okay. Gone, gone. So what do we have now? We have 2xh plus h squared over h. If I were to plug in 0, would I get something other than 0 over 0? Or would I get 0 over 0 if I plugged in, tried it again? I'd still get 0 over 0. So that means we got work left to be done. Okay. We're getting smaller, though. We're getting smaller. So now look over here. Binomial on top, right? Monomial on bottom. What do they all have in common? H. They all got h's, right? So let's factor out an h. So an h on the outside. What does that leave on the inside of the top? 2x plus h, right? And then I have an h on the bottom again, right? Now what can I do with my h's? Cancel them out, right? They become 1s. So now I have 2x plus h. No more denominator. Let's go back to the very beginning now. So now I have the limit as h approaches 0, sorry, f prime of x. For now, it's simplified down to 2x plus h, right? It's no longer that big thing anymore. It's just 2x plus h. Now plug in 0 for h. What do we get? 2x. That is the derivative. The derivative of x squared is 2x. That's not a slope, right? That's not a slope. That's the tool that will help me find the slope if I needed to, but they didn't need me to actually do that. We call this the derivative function or the derivative equation. It's the tool later on today that's going to help me find the actual derivative at a point. Okay? All right. Okay, let's do another one. Let's do another one. Okay. For the function f of x, so we got f of x equals negative 2x squared minus 7x plus 7. It's a quadratic. Find the slope of the tangent line at x equals 5. Does it say the word derivative anywhere in there? Or f prime anywhere? So how do we know this is a derivative question? We do, because you see those 3 words right there, right? You see those 3 words right there. Slope, tangent line.
That's 5.
Slope, tangent line. Slope, tangent line. I just underline of the. Yeah, it was easier to do all of it. Slope, tangent line.
There we go.
That means find f prime of x. That's code for find f prime of x. So it's really asking us exactly what we did the last time. And this one, they actually want us to find a slope. So we're going to do the same thing we did last time, except a little bit more this time. Okay, so here we go.
Doing the same, but a little more.
Okay. All right, here we go.
Same thing, but different.
Same steps, I should say. Sorry, same steps. Okay. There's a minus there. There's always a minus there, and there's always an h on the bottom. Always start with f of x because that's the original. So what's the original here? What's the original f of x for this problem? Look for f of x. Where does it say f of x in our question?
Negative 2x.
Right here. That's going to go right down there. Except there's a minus in between, a minus in front. I'm subtracting everything. So don't forget either to subtract it or I put parentheses just so I don't forget that I'm subtracting everything. Okay. Okay. So now let's go back to the x plus h, right? When I said f of 2, that means plug in 2 everywhere there's an x, right? When I said f of 2a, that means plug in 2a everywhere there's x. What does f of x plus h mean? Plug it in everywhere there's an x, right? How many x's do I have in my original? 2. So I got to plug it in twice. Okay? So negative 2, parentheses, x squared, minus 7, parentheses, plus 7. Okay, so here we go. We got to plug in x plus h and x plus h. It's not as bad as it looks because it's not as bad as it looks. Trust me. Trust me, it's not as bad as it looks because
It's all going to cancel out.
eventually it will. Eventually it will, yeah. Didn't we just do x plus h squared?
Yes.
So don't we know the answer to x plus h quantity squared? Yeah. So we don't have to do that again. And how do I get rid of this second parentheses here?
7x. I know.
How do I get rid of this parentheses here? Distribute. Distribute. Yeah. So we actually know. So let's start with the part that we did already. This part right here we've done before. We just did on the last problem, right? I start with parentheses and exponents first, right? We did that already. So I'm going to replace that with what we did on the last problem. So the limit as h approaches 0, -2 is going to stay in front. What did that become? What did x plus h quantity squared become on the last problem? X squared, keep going.
Plus h squared.
There we go. And then bring everything else down.
This is the cool maneuver for punishment method practicing against.
Okay. Now I'm going to distribute -2 to everything in the parentheses, -7 to everything in the parentheses, and then now I can distribute this negative to everything in the parentheses. So distributive property, which you guys have done many times. So we get -2x squared minus 4xh minus 2h squared, right? That was the first. All right? Now I got to distribute the -7. -7, so minus 7x minus 7h. The next one is that +7. That one doesn't get distributed because it wasn't connected. It was connected by a plus, not distributive property. So that +7 there. Now the last thing was the negative in front of the last parentheses, right? So it'd be +2x squared, +7x minus 7. No more parentheses. H still on the bottom. Okay. What's our next step?
Like terms.
Like terms. Are there any like terms up there? Yeah, there are, right? There's quite a bit, which is nice, right? We want them to go away. So we have +2x squared, or sorry, -2x squared and +2x squared, right? What else do we have that goes away? So there you go, +7x and, okay. And then 7s, right? Yep, +7, -7.
That's it?
More than half of it went away.
Polynomial.
So we have f prime of x equals the limit, oops, not x. So let's see, what's left? -4xh minus 2h squared minus 7h over h.
What a really fancy way of saying 0 over 0.
Well, if we plug in 0, right? We haven't plugged in 0 yet. Some of you have in your head, which is good. Still get 0 over 0, right? What did we do after this? After we got 0 over 0 the second time on the first problem, what did we do after that? What do they all have in common? They all got an h in common, right? So let's factor out an h from the top. So that would be h -4x minus 2h, because that one still has an h, minus 7 over h. The h's cancel out, so that means I can't get 0 on the bottom anymore. Now, what would the limit be as x approaches 0?
As h approaches 0?
As h approaches 0, what would the limit be? -4x minus 7, yeah.
We're going to do anything with that x?
That's
plus 5?
x, that's f prime, right? That's what they asked us to do on the last problem, right? This problem, they want us to find the actual slope. What do we do with limits? How do we solve limits? How do we solve this guy? Plug in 0, right? Plug in 0 there, it goes away. Believe it or not, very little today is actual calculus. Everything you've done, you should have done in Math 1, Math 2, and Math 3. The calculus is so tiny what we're doing today. Okay? So that's why I get a lot of students saying, calculus, this is hard. It's not calculus. This isn't calculus. Distributing? Yeah, exactly. The hard part of this class is not calculus. Exactly. It's just kind of, the students with a good foundation do fine. If your foundation's not as strong, you know. So here we go. At x equals 5. Plug in 5 for x. Negative 4 times 5 minus 7. So the derivative at 5 is going to be what? Negative 27?
Yes.
There you go. So we actually used the derivative this time. We actually used the tool. Last time we just came up with the tool and we were done. This one they actually wanted us to use it. How did we use it? By finding the derivative at 5. So that means if I were to graph this guy and I were to look where x is 5, that's the derivative, or that's the slope. It would be a very negative slope. It would be almost vertical line because that's a very negative slope. Okay, that's what that means. Okay. All right, so let's do the third one. Is exactly the same question, just a different function. Question's the same, function's different. Okay, so let's look at number 3. Okay. So again, so now they want us to find the equation of the tangent line, right? So now, y equals mx plus b, that's an equation, right? I don't have my sign up, I took it down, but those are the equations. It's right here. These are the 3 equations of a line, right? Standard form, slope-intercept form, and point-slope form. Which one do they want us to use? Whichever one you want. Okay? So we're not there yet. We'll get to that part, but that's what we want us to do. Okay. So here we go. Set it up. Slope. Well, the word slope isn't there, right? There's no slope. There's no f prime. There's no derivative, right? How do we know we need to find the derivative? Well, for an equation, you need a slope. For a line, equation of a line, you need a slope. So we need to find the slope. So it's kind of coded in there, right? To get this guy, we need a slope. So let's set it up. F prime of x equals the limit as h approaches 0 h goes on the bottom. The original function goes on the right side. That's 1 over x. The f of x plus h goes on the other side. So what would we get for this guy? What would it look like?
1 over x plus h.
1 over x plus h, good. Because there's only one spot to plug it in, and it's at the bottom. So plug in 0. Do it in your head. Plug in 0. What would you get?
1 over x minus 1 over x.
1 over x minus 1 over x. What is 1 over x minus 1 over x? 0. Over? 0. Work left to be done. This actually looks like a problem that we've done before. Just different letters, But we've done this problem before. Let me find it. Where was it?
I don't know. I'll think about it.
No. Oh, I do. Never mind.
This was like the second lesson we did.
I remember.
It's like the second lesson we did, right? Letters are different. Letters are different, but it's exactly the same kind of outline, right? Instead of X, there's H's, but it's exactly the same thing. You've done it before. Okay? So what did we do? We subtracted the top two. We subtracted this guy from this guy. Anytime we subtract fractions, we need common denominators, right? So what is the common denominator? Let me move this over here so that we have a little more room. Okay. So we got 1 over x plus h, right? Minus 1 over x. That's what we have to do. We have to subtract those two guys. Common denominators. Okay. So this one has a binomial, this one has a monomial there. So the first guy, x plus h, is missing just an x. I need an x. And the second guy is missing the binomial. Okay. So the common denominator is x, x plus h. The first guy is 1 times x, which is just x. The second guy is going to be -1 parentheses x plus h. Distribute the -1. You get x minus x plus h, minus h over x. Okay. Since you've done this before, you don't have to kind of, do the up-down thing. We're looking, writing down, right? You can kind of do this on your own, right? I'm going a little fast here because we've done this before. Okay. I don't want you to get whiplash by looking up and looking down on your paper, right? You can kind of do this part on your own because you guys have done it, right? So the x's cancel out, right?
Possibly.
Well, possibly, or do they? They do, right? X minus x, 0. So let's replace what we got. Let's replace this with what we started with. So let's move this back over here.
Why would you not cancel out -x minus h?
You're talking about this guy here and this guy here?
No, the bottom.
Bottom.
The bottom X?
Or like you have it highlighted, yeah.
This part here? What?
Okay, that's what we're moving.
No, but what'd you say? Cancel out which part?
The -x minus h and then the x plus h.
Oh, they're saying the negative x
Oh.
minus h doesn't cancel out the x.
Because they're not, because this guy is so these guys are monomials. This guy's a binomial. I can't cancel out monomials and binomials. Yeah, good question. Good question though. Yeah, I can't cancel out, I can only cancel out binomials with binomials and monomials with monomials. So the top are 3 different terms. X, negative h. The bottom is 2 terms. X and then x plus h. Yeah, good question though. Why can't I do that? That's good. Okay. All right, so here we go. Let's rewrite this now.
Oh, God, it's triple letter K. It's full. It's still triple letter K.
Okay. So here we go.
If I move the H.
Yep. So we got negative h over x, x plus h, and then we still have that h on the bottom, right? That original h on the bottom that we now haven't touched yet. We've done the problem like this too, right? The top has the top is a fraction, bottom is just an h. If you plug in 0 for h, you're still going to get 0. You'll get 0 on top and 0 on bottom. Okay? Well, it's a division problem, right? Division means we can write it a little differently, right? Division means we can write it like this. Negative h over x, x plus h, right? Divided by h. It's a division problem. Instead of writing it as a fraction, we can write it with a division symbol. Well, how do you divide fractions? Keep, change, flip, right? Keep, change, flip. Keep the first one the same, multiply, flip the second. So we have negative h over x, x plus h, times, flip, 1 over h. The h's cancel out, negative 1 and positive 1, which we like. So you know what, let me move this over here. Okay. So now we have the limit as h approaches 0, negative 1 on top, x, x plus h on the bottom. Plug in 0 for h now. What happens when you plug in h, or 0 now for h? You get negative 1 over x to the second power, right? So the derivative is negative 1 or negative x squared. Okay. They want the equation of the tangent line at 1. Okay, so let's go back to poster here. What do we need for a line? For a line equation, equation of a line, what do we need for it? We need a slope. Do we have a slope? No, we do not have a slope. We have an equation for a slope. We don't have a slope. We have a tool, right? That's like saying, do you have a house? Well, I got a hammer right here. Yeah, you haven't used it yet, right? You build the house by using it, right? Okay? You have the tool to do it, but we haven't done it yet. So we need a slope, and what else do we need? A y-intercept wouldn't be nice. Or instead of a y-intercept, what else could we use? 2 points, a point, just 1 point. Just 1 point. 1 point on the graph. Now, y-intercepts are hard to find unless you graph it, right? And I don't know what I'm graphing right now. And I don't want to graph this guy, right? I think the easier thing would be to find a slope and to find a point on the graph. Okay, so how do I do that? Well, let's start with the slope. How do we find the slope? How do I use the tool to find a slope? Plug in what they said x was, right? What was x? 1. So we're going to go f prime of 1 equals, so that's negative 1 divided by positive 1, which is negative 1. I have a slope. So y minus, so the slope goes there. This is going to be my finished answer here. Not done yet because I have a few blanks, but that's going to be my finished answer, which I'm using point slope form. Point slope form means I need a point, I need a slope. I got the slope, negative 1. Do I have the point? I have half of it. Which half do I have? I have x, right? What is x?
1.
They said x is equal to 1, right? So I'm going to plug it in right there. There you go. How do I get y now?
Plug it into the original.
Plug it into the original. Good. Not the derivative. Plug x into the original to get the point. When do we plug into the derivative? When I want a slope. I already have that. I already got the slope. I want the y coordinate. So how do I do that? Just like Damien said, plug in x, which is 1, right? They told us it was 1, back to the original. What do you get when you do that? Done. Okay. All right. This is very tedious. That's why there's only 4 questions. That's why when you guys look, there's only 1 paper for the notes, right? Because I only wanted to give you 4 problems because it's very tedious. It's algebra heavy, right? Algebra heavy means you're doing all of this stuff here. That's algebra heavy, okay? So
This one's. Can you get another equation now?
let's see, we got about 8 minutes. Okay, so what I want you to do is start this problem. If you don't finish it, we'll finish it on Monday. Okay, so start this problem. We're looking for, here's the function. We're looking for the equation of the tangent line when x equals 12. So it's similar to the last question. Very similar, just different function. I think this one's easier. And not at 1, at 12. So this will be your answer. Your answer will be y minus something equals something, x minus something. You need to fill in those 3 empties. There are much easier ways to find the derivative. I'll show you them next week. I don't like to show them to you at first because then once you see the other methods, you're not going to want to go back to this. And this, believe it or not, this is important because you might see it on the test. I'll show if I remember, on Monday, I'll show you a practice problem and where this shows up. And it's either like you know it or you don't know it. Because either you remember like this means derivative or you don't remember it. So that's why I always include it in the notes. It's either the easiest problem on the test or the hardest problem on the test, these types of problems. So the equation is y minus 144 equals 24 times x minus 12. That's how I figured it out.
Okay, I was on the right track at least.
Yeah, if you didn't finish, it's okay. I get it. It's, you know, we're just running low on time, so I wanted to make sure that I gave you this layout. I'm going to post it on Google Classroom right after, so you'll have access to it. So take a look at it, okay? And then Monday we'll do some practice on this. There's not going to be a lot of problems on Monday because again, each one takes a little bit of time, okay? But it's important to practice, okay?
Anytime I see x squared, I'm just like, okay, what was that again?
The